नमस्ते बच्चों, हमेशा खुश रहो। Myself, Jayoti Dr Monika Trivedi. I have take the topic for today's class as heat of reaction at constant pressure and at constant volume and enthalpy of neutralization. This topic belongs to paper Thermodynamics, Equilibrium and Solution, class B.Sc, B.Ed, PCM ZBC and B.Sc, PCM ZBC, 4th semester. So we start our topic. So what is heat of reaction? Okay, what is heat of reaction? When a reaction is carried out at a constant volume in a bump calorimeter, the pressure within the calorimeter may be changed but no work done. The heats of the reaction in such cases corresponding to del U. Del U is an internal energy change. Ordinarily, the reaction are carried out in open vessels under the constant pressure condition. Del H and del U are however related by the equation. So del H, which is a change in enthalpy, and del U, which is a change in internal energy, plus P pressure and V2 minus V1, which is change in volume. Okay, so we can also write this equation as del U plus del H is equals to del U plus del V. P del V is change in a volume. So the change in volume in a reaction due to the change in the number of moles of gases during the reaction, as we can see in the following reaction. For ideal gases, we can write PV is equals to nRT. So here you can put this value for PV, and we can take here a number of moles like N1 and N2. So N1 moles of the gases are reactant and N2 moles of gases for the product. So we can write here P del V is equals to change in volume, so P V2 minus P V1, or we can write it as N2 RT minus N1 RT. N2 and N1 are a moles of gases, and we also can write it as a N2 minus N1, and RT is constant. So finally we get the reaction is del H is equals to del U plus del N RT. Del N is change in moles of gases. So if N2 is very large than N1, then del H is large, also large from del U, and while N2 is less than N1, then del N is negative. We get del N is negative, so the change in enthalpy is less than the change in internal energy. Okay, if the reaction del V is positive, in the reaction del V is positive, the work is done by the system. Okay, and if the del V is negative, the work done on the system. So basically this is the different the system is working or the work is done on the system. So this is the work done on the constant pressure and temperature. So now we have to learn about enthalpy of neutralization. Simply, neutralization is a process when H plus ions are neutralized by the ion. So at that time some energy released and heat consumption. So in that cortex we have to learn about enthalpy of neutralization. So what is enthalpy of neutralization? The enthalpy of neutralization, which is denoted by del Hn, is a change in enthalpy that occurs when one equivalent of an acid and one equivalent of an base undergo a neutralization reaction to form a water and a salt. It is a special case of enthalpy of reaction. It is defined as a energy released with the formation of 1 mole of water. Okay, when a reaction is carried out under the standard condition at the temperature of 298 Kelvin, which is 25 degrees Celsius, and 1 atmospheric pressure and 1 mole of water is formed, it is called as a standard enthalpy of neutralization. Okay, simply in an exothermic reaction and endothermic reaction, some energy is released. So we know if we take acid and base in a open vessels, then it neutralize each other. H plus ions are neutralized by the OH ions, then some kind of energy release. This energy is in a negative form. We get this energy is in a negative form. So this energy is called as a neutralization energy or heat of neutralization. Okay, here you can see an example when NaOH plus HCl combine and give us an NaCl and H2O. H2O formed by the neutralization of HCl by NaOH. Okay, so what actually happened in this reaction? OH negative ions in aqueous solution and H plus ion in aqueous solution combine and give H2O molecule. So the energy released to form this H2O mole is called as a neutralization energy. Okay, so here you can see some another example, like if you take a weak acid like acetic acid and ammonia solution, it will also give some energy, but it release energy less as compared to the strong acid and strong base. Okay, so weak acid and weak alkali solution has a less neutralization energy as compared to strong acid and strong base. Okay, so here you can see another equation. After seeing this equation, you can get that we can calculate the heat of neutralization by observing the heat of solution. Here you can see the negative sign from of del H neutralization energy, and you can get Q solution. Q is a heat of a solution, plus if you calculate the heat from the colorimeter for that solution, you can find out the total heat of neutralization for that kind of solution. So to calculate the heat of neutralization, you have to use colorimeter. There you can find easily how many heat released by the in a neutralization reaction. Okay, thank you very much. This session powered by Digital Version 2.0, Jyoti Vidyapeeth Women's University. I hope you you satisfied with my this session, and if you have any query, please let me know. Please comment me over there. Thank you very much.